Here we have AP calculus AB problem. Okay, let's go to the information. Find all intervals on which the graph of y equals to x square positive 1 over x square is concave upward. Okay, so here for the graph of the given function, I have to find the intervals where it is concave upward. So whenever I want to find the intervals of concavity for the graph of a function, what I have to do is first I have to find the domain of the given function. So let me write the stuff over here. So once I get the domain, what I have to do is I have to find the first derivative and second derivative of the given function, that is dy over dx, the first derivative. The second derivative is d square y over dx square. Once we get both the derivatives, I have to equate the second derivative to 0 and solve for x. For example, when I equate the second derivative to 0, I am getting two values for x, for say x equals to a and x equals to b. Okay, now what I have to do is I have to mark these two values a and b on the number lines. So let's assume that a is less than b, then we have the left side extreme negative infinity, and so since a is less than b, a must come first and b must come next, and the right side extreme is positive infinity. So when I write these two values of x, a and b on the number line, so I can split up the real number line into three parts. The first interval is negative infinity comma a, and the second part is the second interval, that is a comma b, and the third part is the third interval, that is b comma positive infinity. Okay, now I have split up the real number line into three intervals using the two values of a and b. Okay, now what I have to do is I have to check each of these three intervals with the second derivative, that is d square y over dx square. So for example, I am going to consider one of these three intervals and I take a random value for x in that interval. I plug in the value of x into the second derivative. So when I do so, I am getting d square y over dx square is greater than 0. Then what should I conclude? So I have to decide in that particular interval, the graph of the given function is concave up. Let me write the stuff over here. So whenever the second derivative is, the value of the second derivative is greater than 0 for some value of x, so then we have to decide in that particular interval, the graph of the given function is concave up. So what if d square y over dx square, I mean the value of the second derivative becomes negative, that is less than 0. Then we have to say in that particular interval, the graph of the given function is concave down. So this is what we have to conclude. In this way, we have to find the intervals of concavity. And also, let's consider the domain of the function. So what role does the domain of the function play to find the intervals of concavity? So for example, I'm saying the domain of the function is, for example, it's all real numbers except k. So here the domain of the function is all real numbers except k. In case if you have the value k in the intervals of concavity, it has to be excluded because k has been excluded from the domain. So the same k has to be excluded from the intervals of concavity if you have that k in the intervals of concavity. Okay, now let's see how this stuff works to get the intervals of concavity for the given function over here. So now let me erase everything, and so now what I'm going to do is I'm going to find the domain of the given function. So clearly it's a rational function because we find variable in denominator. So if this x square becomes 0, then the value of y becomes undefined. So actually domain is the values of x for which the value of y is defined. So if x is 0, then this x square becomes 0. Since the denominator becomes 0, then the complete fraction becomes undefined. That is the value of y becomes undefined. So the domain of the given function is all real numbers except 0, because 0 makes this x square, the x square denominator 0. Okay, now let's find the first derivative and second derivative. So for that, let me write the given function as it is, y equals to x square positive 1 over x square. Okay, now to get derivative of this function, I have to use coefficient rule because we find variable in both numerator and denominator. So what is coefficient rule? So let's consider a function in the form u over v, where both u and v are variables. So I want to find derivative of this one. So for that, I have to use coefficient rule. So the coefficient rule is the denominator v has to be squared. The same v should be taken over here. And now we have to get the derivative of the numerator, that is u, then we will be having u prime. Now we have to take negative sign, and also we have to take numerator u as it is, and we have to get the derivative of the denominator v, that is v prime. So this is called coefficient rule. So the same thing we have to do over here. So instead of u, we have x square positive 1. Instead of v, we have x square. So let me write dy over dx, that is the first derivative. So now what I'm going to do is I square the denominator, that is x square the whole square, and I take the denominator x square as it is, and I take the derivative for the numerator x square positive 1 prime negative. Now I take the numerator as it is. I have to get the derivative of the denominator, that is x square prime. Okay, now let's do the simplification, that is x square. Okay, now let's get the derivative of this x square positive 1 with respect to x. So actually this positive one is a constant. When I find derivative of a constant, it will become 0. So the derivative of this x square with respect to x is just 2x. Negative, we have to keep this x square positive one as it is. When I find the derivative of this x square with respect to x, it will become 2x. So over x to the fourth power. Okay, now let's do some more simplification. Dy over dx equals to, when I multiply this x square and 2x, I'm getting 2x to the third power negative. So here we can multiply, you can take this 2x in front of x square positive 1, then I'm getting 2x times x square positive 1 over x to the fourth power. Then we get dy over dx equals to 2x cube. Now we can distribute this negative 2x to this x square. Negative 2x is positive 1. When I do so, I'm getting negative 2x cube, negative 2x over x to the fourth power. So this positive 2x cube, negative 2x cube will cancel. I'm getting negative 2x over x to the fourth power. So when I simplify this x over x to the fourth power, that is x goes into x 1 times. So when I simplify the denominator, this 4 will become 3. So we get dy over dx equals to negative 1 over x cube. Okay, now to do the second derivative, what we can do is we can move this x cube to numerator, because here we don't find any variable in numerator. So when I move this x third part to numerator, it will be multiplied by 1. So whenever I move a term from numerator to denominator or denominator to numerator, the exponent will change its sign. It's already positive. So when it is moved to the numerator, it will become x to the negative third power. Okay, now I got dy over dx. Now what I can do is I can do the second derivative, that is dy, not dy, it's d square y over dx square. So this is the second derivative, which is equal to, so to get the derivative of this one, I have to use a power rule. Power rule means I have to bring this exponent in front of the variable and subtract 1 from the exponent. Then I'm getting negative 3 times x to the power of negative 3, negative 1. So negative times negative will become positive 3 times x to the, when I combine the negative 3 and negative 1, it's negative 4. Actually, so when I'm trying to solve a math problem, if we get negative exponent, we can make it as positive by moving the term to denominator when the term is in numerator. So here x to the negative fourth power, in which we have negative exponent. So if I move this term to denominator, automatically the exponent negative 4 will become positive. Then we get 3 over x to the fourth power. Anyways, let's write the result over here. D square y over dx square, we get 3 over x to the fourth power. Okay, according to the stuff I've explained before I started solving this question, I said once we get d square y over dx square, it has to be equated to 0 and solve for x. Okay, when I equate this d square y over dx square, I mean the second derivative to 0, what will happen? I'm getting 3 over x to the fourth power equals to 0. So will I be able to solve for x in this equation? No. So because even if I multiply both sides by x to the fourth power, so this equation will become 3 equals to 0. It's a false statement. So in this case, when I equate the second derivative, that is 3 over x to the fourth power to 0, I don't get any real value, I mean defined value for x. Okay, so and also here when I find the interval of concavity, I have to exclude 0, because 0 is not a part of the domain. Already we have defined domain for the given function. That is all real numbers but 0. That is 0 has been excluded. The same 0 has to be excluded when I find the interval where the graph of the given function is concave upward. So 0 has to be excluded. And also one more thing we have to notice here. So here we have 3 over x to the fourth power. So in denominator, so x is having even exponent. Already I said that when I plug in some value for x in the result of d square y over dx square, I mean the second derivative, if it is greater than 0, I said it's concave up. If it is less than 0, that is negative, then it's concave down. So in this case, here at the top, like it's a we have positive 3 and this also positive, and overall we have positive sign for this fraction. Okay, so whether I plug in negative value for x or positive value for x, always the sign of this x to the fourth power is positive, because it's an even exponent. So when you take even exponent, even for a negative value, it will become positive. So for any real value of x except 0, so this 3 over x to the fourth power is always positive. That is, it is greater than 0 for all x except, one second left, except x equals to 0. So for all real values of x, this is greater than 0. So since 0 is excluded from the domain, first let's mark this 0 on the real number line. So let's take the extreme value negative, and left side extreme negative infinity, right side extreme positive infinity. So we get two intervals. That is, a real number line has been split up into two intervals, negative infinity comma 0 and 0 comma positive infinity. So here in this interval all values are negative, even when I plug in negative value over here, so this d square over dx square will be greater than 0 because it will become positive. So in this interval we'll be getting only positive values. When I plug in any positive value for x over here, it will be positive, so the complete stuff will become positive. So like except 0 for all real values of x, the graph of the given function is concave up. So the interval of concave, the intervals where the graph of the given function is concave upward is negative infinity comma 0 union 0 comma positive infinity. So we find this particular stuff in option C. So the correct answer choice for this question is option C.